Hello and welcome to day 3 of circles. This is inscribed angles, and inscribed angles are a little bit different than central angles because central angles went to the center of the circle, where inscribed angles are actually the vertex is on the circle. So when you look at the definition here, and make sure you get this down or get down at least the important words of it, the inscribed angle is an angle whose vertex is on the circle. So we need to make sure that we understand that the vertex is on the circle, not in the center of the circle, because that's the difference between inscribed and whose chords are sides of the circle are chords of the circle, and so these are chords, and they can go through and go on forever, or they can stop at the end of the circle, whatever, it doesn't really matter. The arc lies on the interior of an inscribed angle. Its endpoints are called the intercepted arc. So basically what we're saying is from this point here down to this point we have an intercepted arc. This stuff right here is what we would call the intercepted arc, because it's the arc that is made up by the inscribed angle. And so that's the terms that we're going to be dealing with when we are dealing with this, that an inscribed angle is the vertex, which is this point back here, is on the circle, not the center, because that's the difference between a central angle and an inscribed angle. And the intercepted arc is the arc that is made by the 2 points. Well, intercepted arc was the same also in our central angles, because we ended up with it just went, we could have a central angle that should go from here up, and the 2 points are still the same. Now that's what we're talking about down here. So when we're talking about the measure of an inscribed angle, if the angle is inscribed in the circle, then the measure is half the measure of the intercepted arc. So if this was, say, 80 degrees right here for arc AB is 80 degrees, or the minor arc is AB, which is 80 degrees, or the angle ACB is 80 degrees, which is the central angle, then we could say that angle ADB would be 40 degrees, because it's half the measure of the intercepted arc. So it would be half of arc AB or half of the angle ACB. And so that's what we're talking about when we're talking about the inscribed angle. It's half the measure. When we have two inscribed angles that intercept the same arc, then we can say that the angles are congruent. So we have this angle, and I know this is a little hard to see. We have the angle ACB, which we're calling angle C. That angle, if that measure was, say, 40 degrees, would be the same as the angle, which would be 20 degrees down here, because it's half the intercepted arc. Then you'll notice that you're intercepting the same arc for angle D. You're using the same endpoints A and B to get the measure, so angle D would be the same. And it works the same if I could say angle A is congruent to angle B, because they are intercepting the same arc over here, the CD arc. And you'll notice that C and D are intercepting the arc AB, and this one is intercepting the arc CD. So we just didn't write them both down. You'd only really need the top one, but you get the idea that if they're intercepting the same arc, then the angles will be the same. Both of these guys would be 20 degrees. In this one, if we have a right triangle inscribed in a circle, then the hypotenuse is the diameter of a circle. So we have this right triangle where B is the right angle. So angle B is a right angle if and only if AC is the diameter of the circle. Now, why is that 90 degrees? Well, it's still an inscribed angle, because the intercepted arc is this arc A to C, which is a semicircle. So arc AC is a semicircle, which means that arc AC is 180 degrees, which means that angle B is half that, which gives you the 90 degrees that we're talking about. And then finally, we have this last one down here, that if you have a quadrilateral, four-sided shape, inscribed, meaning inside a circle, where the corners are all touching the edge of the circle, then we know that the angles opposite each other, the ones diagonal from each other, are going to be supplementary. So yeah, the angles opposite each other, yeah, if it's angles, opposite angles are supplementary. So for example, in this one, D, E, F, and G lie in the same circle, then if we were to add angle D and angle F, you'd get 180 degrees, and if you added angle E and G, you'd get 180 degrees. Because remember, what we're talking about here is think back to the last one. If I was to draw a line from E to G, then you'll notice that the arc that angle D is intercepting would be half of the circle, or at least half of the circle to the point that half of the where F is not intercepting. Do you see that? And hopefully that makes sense. So this concludes our notes for today. If you have any questions, please come to class prepared to ask them, and please make sure you get this stuff down.